Happy morning, dear friends. Here's yours, Dr. Ajanta. First of all, sorry for the delay uploading due to my tight work schedule. I'm not able to upload the last 2 day session. And here, welcome to day 37 and 38 session. First of all, we are just going to see about Python recursion and Python recursion. That is the recursive function that calls itself again and again. That is what recursion. And recursion is a process of defining something in term of itself. So, for an example, if a physical world example would be to be the place two parallel mirrors facing each other. So, any object in between them would be reflected recursively. That is the main example. You can just easily understand. And see here, dear friends, here I have just shown you the exact image of the recursive function flow. In Python, we know that a function can call other function. It is even possible for the function to call itself. This type of construct or termed as recursive function. And see here, dear friends, let me just have a factorial. And if we are just making this factorial as an example of a recursive function, and the factorial number is a product of all the integer from 1 to that number specified. For an example, if we are just specifying the factorial of 6, it is denoted as 1 into 2 into 3 into 4 into 5 into 6, which results to 720. And let me just make it with an example here. Kindly have a look of it. See here, this is the exact factorial function, and this is the exact thing. If n is equal to 1, that is more than a 1, it's just going to return 1, because whatever multiple the thing with when it just starts from 1, it results with 1. And else, if you are just providing any other number than 1, it's just going to do the function of n into factorial of n minus 1. And here, if you just specified factorial of 3, it would be the result of 3 into 2 into 1, which equivalents to 6. And to the same, if you are just making that function, and see here, dear friends, here the exact explanation is given by a diagrammatical way. That is, when we call this function with a positive integer, it will recursively call itself by decreasing the number. And each function multiplies the number with the factorial of the number below it until it equals to 1. This is recursive call can be explained in this following steps. See here, when we just make use of factorial 3, it is mean 3 into factorial of 2. And if you are just making factorial of 2, it is 2 into factorial 1. And when just coming to factorial 1, it is 1 by 1 again. And when on returning to the third call, it just multiples of 1 into 3 into 2, which returns to 3 into 2. And again, it just results with the 6 as the end of this function. So this is how the exact step-by-step procedure of what is going on. So see here, if you are just making the 3 into 2, which is equivalent to 6. But before that, it has to find the factorial of 2. Here we are just specifying n and factorial of n minus 1, and again 2 and factorial of n minus 1, and again 2 and factorial. And see here, as here it is 1, it is just going to return 1. If it is not, it's just going to make some other resultant of the product of the functionality. Okay, and here I just want to show you one thing, dear friends. When you just one recursion ends when the number reduces to 1, this is called the base condition. Every recursion function must have a base condition that stops the recursion, or else the function calls itself infinitely. So the Python interpreter limits the depth of recursion to help avoid infinite recursion, so resulting in stacks overflow. So by default, the maximum depth of the recursion is 1000. If the limit crossed, it results in recursion error like that. So let just look at such a example. See here, dear friends, if we are just keep on calling the recursor, we don't have any limit. What it just be? It just results to an error. So here, yeah, see here, we want to stop it, and here we have to dead kernel has been done, and it results with an error. Okay, so that is how this happens. So it's just go on infinite. Sometimes in Python lower version you would just receive an error message making maximum recursion depth exceeded. That is recursion error would occurs. Here our kernel has been stopped. Okay, so this is how you can just make use of this recursion. So kindly provide any limit. And there are a few advantages of using this recursion. That is, recursive functions make the code look clean and elegant. A complex task can be broken down into simpler subprogram using recursion. And sequence generation is easier with recursion than using some nested iteration. Even though we have such a good advantage, a few disadvantages are also there in recursion. That is, sometimes the logic behind recursion is hard to follow through. So recursive calls are expensive, that is inefficient, as they take up a lot of memory and time. And recursive functions are hard to debug because it just goes loop on to loop, or iterations to iteration. We have to trace out where the exact error happened. So this was the thing which we proposed to make it in the 37th day session, and let me just move on to 38th day. Here we are just going to see about the Python anonymous, which we just say Lambda function. Okay, what are Lambda functions in Python? See, in Python, an anonymous function is a function that is defined without a name. While normal functions are defined using the def keyword in Python, anonymous functions are defined using the lambda keyword. In opposite to a normal function, a Python lambda function is a single expression. But in a lambda body, we can explain with expression over multiple lines using parentheses or a multiple line strings like that. And here it is the exact syntax of the lambda function. And see here, kindly have a note of it. This is the exact keyword of lambda. And here it is the argument list with the expression. And dear friends, the reason behind the using anonymous function is for instant use. That is one-time usage, and the code is very concise so that there is more readability in the code. There are hence anonymous are called the exact lambda function. And see here, dear friends, lambda forms can take any number of arguments but return just one value in the form of an expression. That is what here it's provided. They cannot contain commands or multiple expression. An anonymous function cannot be a direct call to print because lambda requires an expression. So this is very much important. And lambda function have their own local namespace and cannot access variable other than those in their parameter list and those in the global namespace. Although it appears that lambdas are a one-line version of a function, they are not equivalent to inline statements in C or C++, whose purpose is to stack allocation by pausing functions. So during invocations for performance reasons. Okay, see here, let's see an example to print even numbers without a lambda functions and with the lambda function. See the difference in the line code and as well as the readability. Let me just see with an example below. See here, dear friends, here it is the definition of even numbers, and you're just going to give some numbers, and here we have just declared the list as an empty list. From that, you want to make use of for n in numbers, and you are just making whether the number which is in even, that is an modulus of 2 which is equivalent to 0, that is verifying the even number conditions. And once if it is, you are just going to append it in the en list, that is, and you want to return it as a even list. Okay, so here the exact num list you are just receiving, and after making the verification, or you can just make this process where finding the even number, and you are just going to print it the answer. Okay, so let me just make it a simple thing. Yeah, here 10, 9, 16, 72, 2, 3, 7, 1. These are the number given as an input, and where the even numbers that are listed here are 10, 16, 78 and 2, other than the non even, which we just say an odd numbers. Okay, let me just make the same thing by using lambda function. See here, dear friends, we are just going to give the list L is equal to, this is the function, and even number is equal to list. I want to make a filtration, that is lambda x is colon, that is from the range of x. You are just going to make each and every number, and you want to make the evaluation x modulus of 2 which is equivalent to 0. If it is true, it's just going to return into the list. And what is the even number? That is the exact result. So see how easy this, and how you are able to make this with an easy number of steps too. Okay, let me just show the use of lambda function here. See here, dear friends, here we are just going to have a function x to that of x into 2. The function is a lambda with a keyword lambda, and here x is the argument and x into 2 is the expression that gets evaluated and returned. And this function has no name. It returns a function object where, okay, which is assigned to the identifier double. Okay, and we can now call it as a normal function, that is double of 6, a double of 5, like that. So what it just means is it is just going to multiple it by 2, that is twice the number. That is how it is going to, and here it is the exact result. It is 6 into 2, so it is 12. How easy, within a single line you are just able to execute the function, that is double of. Okay, let me just make use of a normal function here, dear friends. It just gives you the square, okay, and it just going to return x into x. Whereas here the square is equal to lambda, x is equal to x into x, which is the square of, okay, square of the given x. And see here we have just differentiated the both the function, that is square definition square as the normal function, and sqr as the lambda function. And when I'm just calling the 10, it is going to return as 100, and when we are just going to call it by the anonymous, that is the lambda function, it is going to return 4. Let me see the result by executing the coding. Yeah, exactly. See here, dear friends. So both are the simple things, but when on using this as an lambda function, it has special things of making it simpler rather than defining as a separate function. And why we use lambda function when we require a nameless function or a short period of time. And in Python, we generally use it as an argument to a higher order function. That is a function that takes in other functions as argument. And lambda functions are used as long as with built-in functions like filter or map or reduce. And let me just see some of the functionality with the built-in functions. Okay, see here with an example, let me just go for this filter function. And the filter function in Python takes in a function and a list as argument. And the function is called with all the items in the list, and a new list is returned. So which contains the items for which the function evaluates to true. Okay, here is an example using a filter function to filter out only even numbers from the list. And here it is the list 1, 5, 4, 6, 8, 11, 3 and 12, and totally we are having 8 elements with a normal functionality, and making use of this filter built-in function using on the lambda, let it just returns only the even numbers. Okay, fine. And one more example. Let me make use of the same thing, dear friends, by using some negatives also. Here it is specified, and we need only the positive numbers, and let on executing. See here, dear friends. So here the condition what we have just made, if the number that is greater than 0, it is positive number. So put it onto that of list. That's it. Okay, let me just move on to the built-in function map. See, actually map function in Python takes takes in a function and a list, and the function is called with all the items in the list, and a new list is returned which contains items returned by the function for each item. So here is an example in using of the map function, and kindly have a note of it. That is, we want to have a list of 8 numbers, and it is just going to return double of it. Double it in the sense it has to multiple it by 2. And let me just see the output. 2, 10, 8, 12, 16, 22, 6, 24. Because what is the list? So 1 into 2, 5 into 2, 4 into 2, 6 into 2, 8 into 2, and 11 into 2, 3 into 2, 12 into 2. That is what the exact results it has been executed. Okay, next we are having a list of numbers which is just going to return the cube of. Cube is in the sense x into x into x, that is what. And here what is the thing? We are going to have the list 1 as the input, and the list 2 would be the executed output, and where that list 2 would contains the lambda function of the mapping of this number which is given, and we are going to execute it. See here, dear friends. So 2 into 2 into 2, it is 8, and 3 into 3 into 3, it is 27. So like that, we have been used this map function to evaluate the cube of the given numbers. Okay, next is the reduce, and the reduce function is used to minimize sequence elements into a single value by applying the specified condition. The reduce function is present in the function tools module. Hence, we need to import it using the import statement before using. So here I have to make use of that functions tool by importing that reduce function, and then I have to make use of it. And here it is the list 1 which it just has 20, 13, 4, 8 and 9, where what is the thing we have to add is both the elements x and y, which we are just having x plus y. So that is the element we have to make use of each and everything, and then add to the list. Okay, and here addition of all list element is, let me execute it. Yeah, it is 54. So 23 plus 13 plus 4 plus 8 plus 9 is resulted here. And hope you have had a good session here, dear friends, and see you in the next session. Thank you. Bye. Take care.